The Moon orbits Earth in about 28 days. What would be the orbital period of an object whose orbital radius is half that of the Moon? So for this quick problem, we're going to have to apply Kepler's third law, which is t squared over r cubed is equal to t squared over r cubed. So let's label this for our first object and then for our second object here. So for our first object, let it be the Moon. The orbital period is 28 days. So we're plugging that in for our T1. And now the radius of our orbit, we're just going to say is r. Now for this hypothetical planet, moon, whatever it is that's orbiting, we're going to give it a period of t, because this is what we're trying to solve for. We want to know what orbital period this object will have. And we're told that it's at 1/2 the radius of the Moon. So it's 1/2 r, that entire thing cubed. Now, what we're going to have to do is solve for t on its own. So we're going to multiply both sides by this 1/2 r raised to the third. When we do so, we will have t squared is equal to 28 days squared times 1/8 r cubed, because it's 1/2 r, raise that to the third, be 1/8 r cubed, divided by r cubed. Now the r cubes will cancel, and we'll be left with t squared is equal to 28 days squared divided by 8. If we now take the square root of both sides, we would find that t is equal to 28 days over the square root of 8, because you can carry the square root out into both the numerator and denominator, split it up. So 28 days squared, square root of that, give you 28 days. Square root of 8 would be that. So if we now calculate this out, we would find that the orbital period is approximately equal to 10 days. So it'll take roughly 10 days for this object at 1/2 the radius of the Moon in order to make one complete revolution around our planet. So 10 days for it to return to relatively the same position. So E equals 10 days.